Here we have a question from class 10, chapter number 1. Here you have to prove that every odd positive integer is of the form this. See, infinitely many questions can be made and you will be able to sort them also once you gain the main concept. So in this video, I'll not focus on the written procedure and all. I'll focus on the concept. Okay. See, what are these? We must understand this if you have to sort this question. What are these? Okay. 6 is a number, 1 is a number, 6, 3, 5, they all are number. What is 6q plus 1? It's also a number. No? But it's an unknown number because the value of q is not known. Once we know the value of q, we can get this number. No? So this is also a number and this is also a number. Okay, so you can say these are algebraic numbers. So what are we doing with algebraic numbers here, and what does this question mean? Okay, see, algebra, based on algebra, Euclid proposed a division lemma, and he named it Euclid division lemma. Okay. How does it help? It's an important concept of maths which is able to bind all the numbers in few algebraic terms. No? See, there are infinitely many numbers. You won't be able to write all of them. No? That's a tedious task. Okay? But all positive integers can be summarized by two expressions. No? So first one is 2q, the other one is 2q plus 1. No? So what all numbers are included in this formula? All even numbers. Okay? All even numbers are of this form, no? 2 is of this form because it can be written as 2 into 1. Their q is 1. 4 can be written as 2q. For 4, q is gonna be 2. 6 can be written as 2 into 3. So all even numbers are of this form, all odd numbers are of this form. Okay. In fact, if we want to write in terms of 3, it can be written as all numbers are of this form. That's it. Because when we divide by 3, either number will be divisible by 3 or it will leave remainder 1 or it will leave remainder 2. It cannot leave remainder 3, no? Because the divisor is 3. So, 3 is of, let's start from 1. Number 1 of natural number is of the form this. Because when we will divide by 3, the quotient is gonna be 0 and the remainder is gonna be 1. No? So 3 into 0 plus 1. 2 is of this form. 3 is of this form, fully divisible by 3. 4 is of this form because 4 can be written as 3, 1 is a 3 plus 1. 5 is of this form, 6 is this form, 7, 8. So, and in all numbers can be summarized by these expressions also. Okay, so this was proposed by lemma that all numbers can be expressed either by 2q plus 1, 3q plus 1, 3q plus 2, these 3 expressions, or by these 4 expressions, okay, or by 5q plus 1 means 5 expressions. So whole numbers, all the numbers can be used by these expressions. So I suppose now you are able to decode it. What does this mean? That all numbers are all odd positive integers when divided by 6 will either leave remainder 1, 3 or 5. There will not be, none of the positive odd integer is divisible by 6. There is no odd positive integer which will be divisible by 6 because 6q form is missing. No? As per Euclid division lemma, when any number is divided by 6, what are the possible expressions? Either the number will be fully divisible by 6, so of the form 6q, or it will leave remainder 1 or leave remainder 2 or 3, okay, or 4 or 5. Okay, so when divided by 6, these are the possible expression for all the numbers. Number 1 comes here. When divided by 6, when you divide 1 by 6, it will leave remainder 1. 2 is here, 3, 4, 5, 6 is here, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 is fully divisible, 19 will leave. You can see here. Now, this question can be verified here only. Odd positive integer. So 1 is here, expressed by, and 3 is here, means expressed by this. 5 is the odd number, expressed by this. 6 is not, then 7 will leave remainder 1. Okay, 9 will leave remainder 3. So this question is correct. We can prove it. Every odd positive integer will either leave remainder 1, 3 or 5. None of the odd positive integer will be divisible by 6 or will leave remainder 2 or will leave remainder 4. None of them are gonna be so. So this was the understanding part. Now how to write it actually. Okay, so how to write it? For this, I'm not writing much. Okay, so you can write as per Euclid division lemma, when a number is divisible by 6, all positive integers can be. Here I'm writing all positive integers. They can be expressed by these expressions, no? Sorry, not 6. I just went with flow here. So these possible 6 expressions, 1, 2, 3, 4, 5, 6. So these are for all, I must write here. This is for all positive integers. No? Now, so here you can say none of them will be represented by this, because you can say this can be written as 2 into 3q. So all the numbers which are divisible by 6 are actually divisible by 2 also, no? Because 2 is present in the prime factorization of this. See, if you're not getting me, please go to my channel and look at the video of prime factorization. A great tool for mathematics. It will help a lot to understand this if you're not getting it. So what I'm writing, 6q can be written as 2 into 3q, means all the numbers which are divisible by 6, they are divisible by 2 also. No? If you want to divide, they will be divisible by 2. So this is in the factorization of 6q is 2 into 3q. That means 6q will be divisible by 2. That means it's not an odd number. This is an even number. Now here, 6q plus 1. Can you prove it even? No, it cannot be. You cannot take out. See, if you'll divide this number by 2, this term will get divided, but this will not. No, that means it's an odd number. Here, see, you can say when you'll divide this number by 2, so both the terms will get divisible. No? Or on the other hand, you can say that 6q plus 2 can be written as 2 into 3q plus 1. The factorization is this. That means this is also an even number. Okay? And this is, you cannot take 2 common from here because this is 3. So that means this is an odd number because it's not divisible by 2. We cannot take 2 common, that means this is not divisible by 2. Here we can take 2 common as per the factorization. No? So 2 into 3q plus 2. So all the numbers which leaves remainder on dividing by 6, who all leave remainder 4, they are actually divisible by 2. So this is an even number. Okay? And 6q plus 5 here, you cannot take 2 common. That means all the numbers which leave remainder 5 will not be able to divisible by 2. That means they are odd. So this proves actually that all odd numbers are of the form this, this and this. They are never of the form this, this and this. Because a number is either even or odd. No? It cannot be a number cannot be even and odd both. So this was the understanding part. you may refer to your book to look for the presentation, and basically the concept matters. Then you can present the things yourself also. So whenever you face such questions, just understand these three things, okay? And then writing part is always come. It means for me it's always secondary, because once you know the thing, you can actually write anything, no? So that's all for this. Thank you.